Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to show you guys how you can find the determinant of a 4 by 4 matrix. So there will be two examples in this video, and we're going to start off with this example right here. Well, before you can think about the formula of finding the determinant of this matrix, you need to decide whether you're going to do it based on the column expansion or row expansion. And as I've mentioned in the previous video, what you need to consider is the number of zeros, because when you have a lot of zeros, then you'll be able to save the process of getting the result. You don't need to do all the process related to finding the minus and the cofactors, because when you have zero entries here, then everything is going to be zero, right? And based on this matrix here, we can see that our job is going to be much more easy if we consider finding the determinant of the matrix based on the third column expansion, because it has the most zeros in it. Okay, so now we are going to consider the third column expansion. Okay, so this is what we're going to do, and according to this idea, we can find the determinant of this matrix using this formula. So here we have this position here is at A13, C13. Next, this is A23, C23 plus A33, C33 plus this position here is at A43, C43. And we can see that this is 0, so this part here is going to be 0, definitely, because A13 is 0. This is 0, so here is going to be 0. And this is 0 also, so here is also going to be 0. Therefore, like I said just now, we have reduced a lot of steps. We don't need to find the cofactors for these three items right here. So the formula now has become very much simplified. So we have A23. What is A23? I'm just going to substitute the number right away. A23 is 2, so we have 2C23. Okay, so this is what we need to find, and our job is just to make sure we find C23. Okay, so to find C23, we need to find what is M23. Now, M23 can be obtained if you consider deleting the second row and the third column. Okay, and consider other values. So we have 9 remaining values that you need to consider. So we have 2, -3, 1, 1, -1, and 3, -2, 1, and 0. Okay, now we need to simplify the process again. How can we find the determinant of a 3 by 3 matrix? Unfortunately, there is no simple way to do it. You need to consider repeating the process, thinking about what row or what column expansion that you need to do in order to find the determinant of this matrix. Now we are going to repeat the process. For example, you can consider the third row expansion. Okay, for example, in order to find what is M23, you can consider third row expansion. So consider the third row expansion. Therefore, M23 can be obtained, okay, the determinant of this matrix, which is M23, can be obtained if you consider what is this position. Now this is a 3 by 3 matrix, yeah? So the position here is going to be A. I'm going to use a different notation just to differentiate with the result, or maybe that's okay. I'm just going to use this notation. So this position is A 3 1, yes, A3 1. So the cofactor related to that is C3 1. Next, plus A3 2 C3 2 plus A3 3 C3 3. Okay, and that can be simplified as, so negative 2 C3 1 plus 1 times this is C32, 0 times this is going to be 0. Okay, so now we need to find what is C31, because we need to plug in the result here. Okay, so C31, so we have different level right now because our matrix is not simple anymore. We have 4 by 4 matrix. Okay, so in order to find what is C31, we need to find what is M31. So M31 is going to be, in order to get M31, you need to delete the third row and the first column of this matrix here. So you're going to delete third row and first column. So the result here is going to be negative 3, 1 that you have to consider, negative 1 and 3. And now we have got a 2 by 2 matrix which you can find the determinant of it very easily. So here we have negative 9 minus negative 1. So this is negative 8. And hang on, we're not done yet because you need to find what is C31. So C31 is just negative 1, 3 plus 1 here is 4, and the result here just plug in right next to it. So you will have positive, negative, so the answer is negative 8. And then you go back to this part, negative 2 times negative 8. Okay, so just plug in the result right there. Okay, so what we need to do next is we need to find this result, C32. And because I don't have enough space, I'm just going to erase. Oh, maybe I have space, so I'm just going to consider this part, C32. So I need to find what is M32. So in order to find M32, I need to delete the third row with the second column. Okay, so here I have the remaining values, which are 2 and 1, 1 and 3. From there, I can obtain the determinant of a 2 by 2 matrix very easily. So here we have 6 minus 1, which is going to be equal to 5. Therefore, C32 is negative 1, 3 plus 2 is 5, plug in the result here right next to it. So negative 1 to the power of 5 is negative 1, so the result is going to be negative 5. And I'm just going to put the result here, negative 5. 16 plus negative 5 is 11. So here is M23. But we are not done yet because we need to find what is C23 to be plugged in right here. So I really don't have space, so I'm just going to erase this part. Alright, so we've got the result of M23. Using this result, we're going to find what is, therefore C23 is going to be negative 1, 2 plus 3 is 5. And then this result here, 11, just plug in right next to it. Negative 1 to the power of 5 is going to be negative, so here it's going to be negative 11. And we can now use this result to plug into this main, our main work here is 2 times negative 11, which is negative 20. Okay, so that's the answer for finding the determinant of this matrix, and I obtained this answer by using the third column expansion. Now if you want to try and do it at home, why don't you try, just for the fun of it, why don't you try get this value here, but perhaps using the, I don't know, maybe fourth row expansion. Okay, go ahead and try and do it, and hopefully you'll be able to get this same answer right here. Okay, there's another example. We have 4 by 4 matrix. Of course, by looking at it, I'm sure you can find the determinant of a matrix easily if you consider again the third column expansion. Why? Because we have a lot of zeros. When you have a lot of zeros, you reduce your effort significantly by not having to find all the minors and the cofactors. Yeah. However, why don't, just for the fun of it, let's choose a different expansion. Maybe, let me see. Maybe we can find the determinant of the matrix if, or by considering perhaps the fourth row expansion. So this looks slightly complicated because here we've got 2 zeros. This column here, we got 3 zeros, so that is the easiest one. Maybe you can try and do it at home, but right now, just for the fun of it, let us try and solve this example using fourth row expansion. Okay, right, so using fourth row expansion. So determinant of this matrix, I'm just going to call this matrix A. So determinant of A can be obtained if you consider this position here is A for 1, so C for 1, plus A for 2, C for 2, plus A for 3, C for 3, plus A for 4, C for 4. And we can see this one here is going to be 4 times C for 1. This is going to be 0, this is going to be 0, so this is going to be cancelled out. And plus 8 C for 4. Okay? Right. Now we begin our process of finding C for 1. And in order to find C for 1, you need to be able to find M for 1. To find M for 1, you should delete the fourth row and the first column. Therefore, here we have a 3 by 3 matrix, which is negative 1, 0, 3, 0, 5, 7, 9, 0, 2. And to find the determinant of a 3 by 3 matrix, again, you need to think of whether you want to do it in terms of column expansion or row expansion. Okay, now let's say that we consider the second column expansion. So let's say we consider using second column expansion, because that's the easiest, right? We have 2 zeros right there. Okay, therefore M for 1 can be obtained if you consider this is A12 C12 plus A22 C22 plus A32 C32. This becomes 0, 0 times this, 0. This becomes 5 times with C22, and this also becomes 0, okay? So M for 1 is equal to 5 times with C22. Now, the next level that we need to consider is, we need to consider how to find C22 based on this matrix, 3 by 3 matrix, okay? So, to find C22, you need to delete, before you can find C22, you need to find M22, M22, and you need to consider deleting the second row and second column, okay? Therefore, your matrix is going to be reduced to negative 1, 3, 9, and 2. And here you can find the determinant of this matrix quite easily. This becomes negative 2 minus 27, which is negative 29. Now we can go find the value of C22. This is just negative 1. 2 plus 2 is 4. Negative 29 that you got over here, just plug in right next to this item. So positive, negative, the result is negative 29. And therefore, I'm just going to plug in the result here to this part, okay? Therefore, M41 is going to be 5 times negative 29. So 5 times negative 29 is negative 145. Okay, so that is M for 1. But what we need is C for 1. So don't forget, go ahead and find what is C for 1. C for 1 is negative 1. 4 plus 1 is 5. And then here we have negative 145. Okay. So this one here is negative 145. The result is going to be positive 145. Right? And plug in this result at this position here that you're looking to find. So here we have is equal to 4 times 145 plus 8 C44. So you need to find what is C44. Let me just, no need to write it again. So our job is to just find the value of C44. And to find the value of C44, I just need to erase the space. This one here. Okay. Okay, right. So C44 can be obtained by first considering M44. So M44 is obtained by deleting the fourth row and the fourth column. So we have the remaining values of 2, negative 1, 0, 1, 0, 5, 7, 9, 0. Okay, now, of course, the easiest one is this one if you want to find the determinant of this 3 by 3 matrix. But, let's say for the fun of it, we choose doing it by second row expansion. Okay, just to demonstrate the slightly difficult way of obtaining it. Okay, so let's focus on second row expansion. So using second row expansion, you can find that M44 is going to be given by, at this position is A21, so C21 plus A22, C22. This is A23, C23. And here it will be simplified to 1 times C21. And here is going to be 0, 0. This one here is going to be 5 times C23. Okay. Well, now we need to find what is C21. So here we got another level. Okay, we're going down the next level. To find C21, we need to find the result of M21. So M21 here can be obtained if you consider deleting the second row and the first column. So we have a matrix of negative 1, 0, 9, 0. So here if you find the determinant of it, it's going to be 0 minus 0. Therefore, automatically c to 1 is just going to be equal to 0. And well, we just plug in the result here. This is equal to 0 plus 5. Now our job is to find the value of C23. To find C23, we need to start off with finding M23, which can be obtained if you consider deleting the second row and the third column. So here you have values of 2, -1, 7 and 9, and so the determinant of this 2 by 2 matrix can be found easily by multiplying 18 minus -7, which is equal to 25. Therefore C23 is -1, 2 plus 3 is 5, and the result here you just plug in next to it. This one here is going to be negative, so C23 is just -25. Okay, so go on and write the result at this position. So M44 is just -1 to 5. Okay, -1 to 5. Remember, we need to turn this result into C44. So C44 is equal to -1. 4 plus 4 is 8. Plug in the result here right next to it. I'm sorry for I don't have enough space here. So this part here is going to be positive, -1 to 5. So final result is -1 to 5. Okay, and plug in this result at this position. So here we have 8. C44 is -1 to 5, and if you punch in these values into your calculator, you will get the result as -422. So this is the determinant of 4 by 4 matrix given here. Okay, all right, I think that's all for now. Perhaps what you can do next is you can go on and try to find the determinant of this matrix using the third column expansion, which is, you know, a lot easier than using the fourth row expansion. And I hope you'll be able to get the result is the same as this one, which is -420. Thank you very much for watching, and I'll see you in the next video.